sklearnmetricshingeloss. Description: the hinge loss is a loss function used in the context of binary classification. It measures the misclassification error by penalizing incorrect predictions based on the margin of the decision boundary. Inputs: y true, the true labels of the data points. It should be a one-dimensional array of binary values 0 or 1. Y pred, the predicted labels from the model. It should also be a one-dimensional array with the same shape as y true. Outputs: loss, the hinge loss value representing the overall misclassification error. It is a scalar value. Steps: calculate the difference between the predicted label y pred and the true label y true for each data point. For each data point, if the difference is greater than or equal to 1 correctly classified with a margin, the loss is 0. If the difference is less than 1 incorrectly classified or correctly classified but without a sufficient margin, the loss is 1 difference. Sum up the losses for all data points and divide by the number of data points to get the average. Hinge loss. Metrics. None. The hinge loss itself is a metric representing misclassification error. Visualization plots. None. Hinge loss doesn't directly translate to a visual plot like a confusion matrix or ROC curve. Fine-tune parameters. None. The hinge loss doesn't have any fine-tuning parameters. Uncertainty methods. None. Hinge loss does not provide a direct measure of uncertainty. Challenges and fixes. Challenge 1: outliers can disproportionately affect the hinge loss calculation. Sample use case: a single outlier with a very large prediction error might dominate the loss calculation, leading to a misleading overall measure. Fixes: consider robust loss functions like Huber loss that are less sensitive to outliers or apply data preprocessing techniques to handle outliers. Challenge 2: the hinge loss function is not differentiable at the point where the predicted label equals the true label. This can pose a challenge during model training with gradient-based optimization methods. Sample use case: while training a model with hinge loss, the gradient might be undefined at certain points, making it difficult for the model to learn effectively. Fixes: use regularization techniques or smoothing methods to make the loss function differentiable or use optimization algorithms specifically designed for non-differentiable functions.